So we are starting with transformations, horizontal and vertical translations of functions. So we're starting off with horizontal and vertical and then reflections. So none of that is really new. The only thing that there will be a different reflection. So last year you would have done stretches about the x-axis, vertical stretches about the x-axis, which was the a value. And then you did reflections in the x-axis if this was negative. Then this was a horizontal translation, opposite direction. Vertical translation, same direction. We agree? Okay. If you do as I say, it won't get all tricky. So we can either, a translation is a transformation that slides each point of the figure the same distance in the same direction. So we're either going to move left or right, or we're going to move up or down. Okay? Now, if you have it in this form, which we will this year, you'll have the k on the left-hand side. What I would always suggest before you list any transformations or do anything to the equation is always get it in y equals. Okay? So I always get it into this format so that you're always sticking to the same thing. If you want to keep it on this side, that's fine, but then always stick with it on this side. Pick a side to make it look like, and then just always do that so that when you see the k, it's always I do that. When I see the h, it's always the opposite kind of thing. Okay? Now, this here, x minus h, the reason why you always go the opposite direction, left or right, is because there's this hidden minus sign directly into the formula, is there not? So if I go x minus 3, people will try and tell me it's 3 right. But in order to have a minus 3, I actually have x minus h. We agree? So what would my h actually be? This is my x. This is my minus sign. My h is actually what? Plus 3, is it not? Agree? So it's actually 3 to the right. So that's why it's always the opposite of this one, because it has that minus sign in it. Whereas k has a plus sign in front of it, right? So if I have a plus 4 at the back, k is 4, right? It's not any different. So let's look at the h again if it was a minus sign. So what if I had x plus 4? Why do you suppose that that is actually 4 to the left and not 4 to the right? The formula has a minus sign, does it not? So this is really x minus is what it has to be, correct? And then something. So what would I have to make this something be in order to get positive 4? What times what gets me positive 4? Negative 4. So a negative times a negative is actually a positive. So that's why you're going 4 to the left, not 4 to the right, because your formula has x minus, no matter what. It's just that because I had a minus, the minus, it turned to a plus. Does that make sense? So that's why the h value is always the opposite direction, because of that minus sign. Does that make sense to you? If it doesn't make sense, you're memorizing. And if you memorize, that scares me, because memorizing can make oopsies, right? If you understand, people can throw anything at you and you'll get it. Got it? And the k's, you just do what you do, because there's no minus sign in here. It's just a plus, right? So if it's plus 7, it's 7 up. If it's minus 7, it's 7 down. The way you say it always is you'll say horizontal translation of 3 units left, or horizontal translation 4 units right, vertical translation of 6 units up, vertical translation 6 units down. You have to say it like that, okay? You can't just say 6 units down. You have to say vertical translation 6 units down, okay? Mapping and replacement notation. So you're really just getting filled in on a whole bunch of stuff right now. Mapping. Mapping is what you actually do to the points, okay? So if I said I moved 3 right, which of my variables would be affected on a coordinate if I moved 3 right? The x would, correct? And how could I move x 3 right? What would I have to do to it? X plus 3. Now, why would we do a generic one like that? Because if our graph has a whole bunch of points, and I have x plus 3, I can fill in every single point and it will move my x correctly. We agree? Now, y is going to be my vertical translation. So if I move 6 down, I'm going to take that y value and I'm going to minus 6 from it, correct? Right now, mapping notation sounds silly because you could just add 3 to the x's and minus 6 from the y's. Why would I write out a mapping notation? Because in 2 days, we're going to have stretches and reflections as well, which is way more complicated than just moving left or up or down, right? Right or left or up or down. So you need to know mapping. Mapping is your best way to move points. So if I have it in this form, y minus k equals, I would go y equals f x minus h plus k. We agree? I'm moving h right. I'm moving k up. We agree? So I'm going to go x plus h, y plus k. Why do I need to know variables? Because they don't have to put a number in the question, do they? They could just use variables, just like that. So we use mapping notation when we're moving coordinates. And coordinates are just a fancy word for points on your graph. So if at any point in time you're moving coordinates, you're moving a coordinate, you're going to use mapping notation. If you're moving an entire graph, you're going to use mapping notation because you're moving coordinates, right? A whole bunch of coordinates. A graph is just a whole bunch of coordinates. That's all it is. Okay? Replacement notation is what you use when they give you what you're doing and you have to come up with a new equation. So it's when they give you the transformations. And you need to make the new equation. So why is grade 12 a little bit harder than grade 11? Because it's a full unit. It's going to be applied to a whole bunch of equations, not just quadratics. And you're going to have to be given translations and transformations and come up with the equation. You have to be given an equation and be able to come up with the transformations. If you're given an equation, come up with the graph. If you're given the graph and come up with the equation, right? So it's all working backwards and forwards. I can give you any piece of something and ask you something about it. That's why it's more complex. But we start off nice and easy. So in this case, the graph of y equals f of x. Now they're going to put little f's into all your equations, okay? And you started really looking at function notation for the most part in grade 10 very basically. We looked a little bit in grade 11, but for the most part we did quadratics and that was it. In grade 12, we're going to have a whole bunch of functions, okay? Up until now, you've always had functions that actually are an equation, like y equals x plus 3 squared minus 2, or y equals 3x plus 7. And they're actually equations you can type right into your calculator and look at them. We agree? But now they might give you a function like this. We agree? Is there any equation that represents that? Can I type anything into my calculator and poof, it'll pop that up? No. So they'll tell you that this is still a function, because if I drew vertical lines, it would pass the vertical line test, correct? What's the vertical line test? That's if for every x, there's only one y. So if I draw a vertical line, it only crosses through once. We agree? And the entire way, if I draw millions of vertical lines, they're never going to cross through more than once. We agree? Okay, so this is a function, so still good. We just need functions. They'll label this, say, g of x. So say they call this g of x, right? So now they'll write this as y equals g of x. So they're telling you it represents this graph. Okay? Why would we use g's and f's and x's? Because sometimes they can put another graph on here. Say they label this one f of x. Well, that would be the equation y equals f of x. They need to label them different variables so that when they have more than one graph on a Cartesian plane, that you know which one they're even talking about. If they labeled them both f of x, how would you know which one was which? If they labeled them both y, you'd be really in trouble, right? I don't know which one you're talking about. But this way, when they have a little f in here, they're talking about the f of x graph, okay? So that's why there's those little f's in there. They also have these little f's in here because there's no way you can put a little f into your y equals on your calculator. So you're not typing it in. The moment it has a little f in here, you need to know your stuff. You can't type into your calculator and see what it looks like because you can't type it into your calculator, which trumps up last year. So some people would just take their equation and they'd type the equation into their calculator and see where it moved from x squared and then say the transformations from it. You can't do that. You can't type in the new equation based off the old function if it has an f in it. You can't type it into your y equals. So you need to know your stuff. Okay? So this is my new equation. This was the first equation. It's been transformed to this equation. We agree? Basic equation with no transformations, new. So we are going to get y equals f x minus 3 plus 2, because I moved the 2 over by adding it. We agree? Does this f do anything to the graph? No, this f just says it's a function f. So if I went to draw this graph or move a graph that was already drawn, I move the f graph. That's all it means. Can I type this into my calculator? No. The moment there's that little f there, that's all it means. It's just the function f. So if they actually gave me a graph and it had an f, a g, and an h on it, I would only move the f graph. Does that make sense? So don't let this f throw you off. If it's in the brackets, it affects the x. If it's not in the brackets, it affects the y. It's very important. Okay? If it's in the brackets, it affects your x variable. If it's outside of the brackets, it affects your y. Something to note. We're going to write that. In the bracket affects your x variable. Not in bracket affects your y. So when people are sitting there for life trying to figure out which variable it affects on their graph, if it's in the bracket, it affects your x. If it's not, it affects your y. That's it. It's very easy. Okay? So if it's in that bracket, your x variable is moving. If it's not, your y variable is moving. So we'll deal with the replacements after. But this one here, the mapping is what I want to look at. The mapping for this coordinate, the original, would be xy. We agree? But the new function's mapping is actually x plus 3 because I moved 3 to the right, and y plus 2 because I moved a vertical translation 2 up. Okay. So if the point 4, 6 is on the graph of y equals f of x, so 4, 6 is on the original. That's what they're saying. And we have to read thoroughly because sometimes they'll give us a point on the new and they want the original point back. So we have to read very closely as to what they're giving us and what they want. So if the point 4, 6 was on the original y equals f of x, then the point would become 7, 8 on the new. We're moving a point. How do we move points? Mapping. Okay? So our original coordinate is x, y. And what's our new one on the new? X plus 3, because we moved 3 to the right, correct? And y plus 2. Do you agree? So let's fill in our original point, 4, 6. This is just proving that it actually does become 7, 8. So if I have the coordinate 4, 6, I just plug 4 in for x now and 6 in for y and see what I get. So 4 plus 3, 6 plus 2. And so I get 7, 8 is my new coordinate. And it's right. We agree? Okay. Alrighty. Describe how the graphs of the following functions relate to y equals f of x. So this is my original. Does my original have any transformations on it yet? Y equals f of x, is there any transformations on there? Nope. You have to look if there's already transformations. If they exist already, then you don't state them on the new one. So if it already was a plus 3 at the back, and then on my new functions I still had a plus 3 at the back, would I state that there's a vertical translation? No, it was already there. Okay? All right. So here we have y equals f of x, x minus 3. So it's in the bracket with it, is it not? So is it a horizontal translation or a vertical translation? Horizontal translation what? 3. Left or right? Right. Why is it right? Because it's actually minus a positive 3. So it's 3 to the right. Remember that minus sign is always there. That doesn't actually affect it. It's the sign of the 3. What's this one? Is it with the x? Is it in the bracket? No. So it's a what translation? Vertical translation. 4. Up or down? Because it's whatever it is, right? It doesn't change. It's vertical. You try C and D. Is this with the x in the bracket? No, so it's what? Vertical translation 8 down. Can I just write 8 down on the diploma? Will they give me full marks for that? No. Because that means you can't remember if it's vertical or horizontal, so you're just going to write 8 down in hopes that they'll give you the mark for it. It's not going to happen. Okay? It's vertical, you got to write it. Okay. This one is I'm going to do vertical first, so I feel like it. Vertical translation. I always just do verticals first. Vertical translation 4 up. Horizontal translation what? 7 left, because it has to be a negative, right? In order to make that positive, so it's actually to the left. Example 2. Did I push this thing? Example 2. What happens to the graph of the function y equals f of x, that's your original, if the following changes are made to the equation? They want you to take the x, grab it, huck it out, and replace it with x plus 2. So we're going to go y equals f, and instead of having an x, I'm taking that x, I'm physically ripping it off the paper, I'm throwing it across the room like a football, and I'm replacing it with x plus 2. So I'm going to have 2 x's in there. No, I physically took that x, I threw it across the room like a football, and I inserted x plus 2. That's what replace means, right? Okay, so what happens? What transformation do I get? Horizontal translation 2 left. Because it has to be a minus to make that plus. Now we're going to take the y of this function up here. I'm going to rip it off the paper. I'm going to throw it across the room, and I'm going to replace the entire y with y minus 8. We agree? So I get y minus 8 equals f of x. And then preferably myself, this is what I always do. I always get into y equals. So y equals f of x plus 8. And now what do I have? A vertical translation 8 up. The next one says the point 2 and negative 3 lies on the graph of y equals f of x. So it's on the original, correct? That's an original point on the original equation. State the coordinates of the image of this point under the following transformations. So they want the new point if these transformations happen. Okay? I'm moving a coordinate. What should I do every single time I move a coordinate? Mapping. Yeah. So before I even touch the coordinate or do anything with that coordinate, I'm going to figure out my mapping notation. So my original coordinate's xy. Nothing has happened to it. It always is xy. What's my new coordinate? Well, preferably what I'm going to do is rewrite this. Y equals f of x minus 8. So what do I have here? What kind of transformation? Vertical 8 down. Is it in the bracket with the x? No. So does it affect the x? No, unless it's in that bracket with the x, it affects the y. So my x, nothing's happening to my x. It's just a little x just sitting in that bracket, right? The x is sitting alone in that bracket. Nothing's happening to it. So my coordinate x is going to stay the same. And my y, I'm going to do what to it? Something 8. Subtract 8 because I'm moving 8 down. And I do as I say, right? So my original point was 2, negative 3. And it's becoming 2 and then negative 3 minus 8. So what's my new coordinate actually? 2 and negative 11. Now you might say, well, I could have just done that in my head. True. Very true. Probably all of these you could do in your head. But once I add stretches and reflections, it's going to get messy. So it won't be messy at all if you just use mapping. So whenever you move a coordinate, use mapping. It's very easy. Okay? Try B. And then try example 4. This was all taught last year. So, well, except for like mapping and stuff. Try B and then A, B, C in example 4. So the mapping for this one is x, y becomes what? X plus 7, y to my coordinate 2, negative 3 becomes 2 plus 7, negative 3 plus 5, which is 9 and 2. Okay. Write the equation of the image of y equals f of x after each transformation. So horizontal translation of 5 units left. So my replacement would be that my x would become what? X plus 5. Yeah, we would take that x out, we'd replace it. That's what replacement notation is. Just a quick look at it, okay? So you have y equals f of x plus 5. That's really what you needed to show me, okay? Vertical translation 3 up. My y would actually be replaced with y minus 3 so that I could move it over and it would be a plus 3, right? So replacement notation is always the opposite if they did have to ask you for a replacement notation. So we're going to get y equals f of x plus 3. Okay? Putting the plus 3 on that side is absolutely fine, but there's going to be a catch when we add stretches and reflections. Just keep that in mind. Horizontal translation m units right. So we're going to get y equals f m units right. So x minus m. And then vertical translation p units down. Then it's going to be minus p. Okay. We're moving a graph. A graph is made up of coordinates. When we move coordinates, we use mapping. So that's what we're going to do. So this one is x comma y is going to become what? The very first thing I need to do is always look, my original, did it have any transformations on it? No. Because what if my original was y equals f of x minus 2? This would be a trick question. If my original was that and it transformed to this, I'd be done. Right? Nothing's changed. We agree? If my original was this and my transformed was this, would I move anywhere right or left? No, but I would move up or down because these would be the exact same, right? So you always have to look at your original because if it has been moved already, that makes a big difference, okay? Because then it's still not moved if it's the same. Does that make sense? We always have to look at our original. We just assume that they're not moved, but sometimes they already have been transformed. Okay, so this is going to be x what 2? Plus 2, comma, y. So all my y's are staying the same. All my x's are being added to. Like I said, this is going to seem ridiculous when we're just doing translations, right? Because you could just move them all 2 to the right and nothing with your y's. So I'll let you do that after, but I just want to show you because it's going to get more advanced very quickly in the next couple of days. So here we have 1, 2, 3, 4, 5, 6. So we have -6 and 0. So it's going to become -6 plus 2 and 0, which is -4 and 0. Now on these particular equations, could we just keep the y's the same and move all the x's 2 to the right and not do mapping? Absolutely. Will they give something this easy on the diploma? Probably not. We're building, right? We're building the things in. So as long as you understand mapping is this, for today, if you want to move all the coordinates just 2 to the right, I don't care. That's fine. Now, because I'm only moving 2 to the right, I can still see the shape, right? And I can still draw it. But once you're moving 2 to the right, stretching it horizontally by a factor of a half, reflecting it in the x-axis, when you're doing all of that, it's going to be a lot harder to realize maybe which points connect to which points. So what I would suggest you do is, okay, I found the first one, I moved it 2, I found the next one, moved it 2, connect them right away. So you know which actual points connect, rather than at the end you have random points and you're hoping to connect them correctly, right? Now I move this one 2 to the right, so now I connect it. I move this black one to the right, so now I connect it. I move this last one to the right, so now I connect it. So I would move the point and connect right away. As of right now, not too tricky. Will it get tricky in the next 2 days? Yes, a lot more tricky. Okay? So I'm teaching you good skills so that when it does get way more advanced than this, you do it. So when it's way more advanced, I would do mapping for every single important coordinate, all these turning ones. Okay? Could you do that now? Nah, you just can move it to the right, obviously, just fine. Okay? This one, I'm going to rearrange my equation. I'm going to get y equals fx plus 3 minus 2. So what would my mapping be? It would be xy becomes what? X plus 3 or minus 3? Minus 3 because it's 3 to the left. And y minus 2. Remember that mapping is just what you're doing. So if you say I'm horizontally translating 3 to the left, I'm going to minus 3 because you're just doing what you're saying. Mapping is just literally moving the coordinates like what you're saying, right? So it's exact same. It's not tricky. You don't flip them or anything. If you're moving 3 to the right, you minus 3. If you're moving 2 down, you minus 2, okay? So if I check the point in here, I can check this one. It's 1, 2, 3, 4, 5, 6, 7, -7, -7 and 2. So it's going to be -7 minus 3 and 2 minus 2. So my new point is going to be -10 and 0. Could I just move all the rest 3 left, 2 down? Do I have to do mapping for every single one? No. When it gets more advanced, am I going to do mapping for every single point? Yes. So 3 left, 1, 2, 3, 2 down. Then I connect them. Remember, I'm teaching you good skills so that when it's more advanced than this, you're still fine. Okay? You still find it just as easy as you do now. 3 to the left, 1, 2, 3, 2 down. Connect. 3 to the left, 1, 2, 3, 2 down. 3 to the left, 1, 2, 3, 2 down. Oh, my board is shaking right now, but it's annoying me. Make sense? For example 6, what I want you guys to do is I want you to give me the new point using the mapping they gave you, and I want you to state the transformations. So horizontal translation, blah, vertical translation, blah, okay? So I want the new point, and I want you to actually state the transformations from the mapping and see if you can do that. Because sometimes they'll give you mapping and ask you for the transformation. See if you know what to do. You can do it on the easy ones, you can do it on the... So it says state the coordinates of the image of the point -3, 5 under the transformation. So they want the transformed one, right? They don't want the original. They gave it to us. They want the transformed one under these transformations. Remember, we need to read it, make sure they know what the heck they're asking us. So our original is -3, 5. And we're going to have -3 minus 7, 5 plus 4. Once you have your mapping done, it's brainless to do the math, right? Like, It's just really elementary math after that. So the hardest part is getting the mapping. After that, it's literally just plugging in and getting an answer. So the mapping is the important part. So we have negative 10 and 9 is our new point. And what are our translations? We have a horizontal translation, what? Seven. Left or right? Left. Why is it left? When it was the opposite in the equation. It is left, you're correct. But why is it left when it was the opposite in the equation? Yeah. Yes. This is literally just math, right? I have an x coordinate. I'm minusing 7 from it. If I'm minusing 7 from the x coordinate, where is it moving? Left. Okay? If you understand what you're actually doing, this is a really easy question. If you're memorizing that mapping means the same, but in the equation it means opposite, when you're memorizing, that's scary, right? If you understand, it's way easier. This is literally just a coordinate. I have an x value. I'm subtracting 7 off that x value. I have an x value. I'm subtracting 7 off that x value. I am moving to the left. I have a y value. I'm adding 4 to it. I'm moving up. Right? If you understand, this is really easy. It's people who memorize transformations that scare me. Okay? And they should scare themselves. Okay, so it's 7 left because I'm subtracting 7 from my x coordinate. And it's a vertical translation for up. Okay, then this one, I have negative 3, 5, and it's negative 3 minus 6, 5 plus 1. I'm going to get my new point, which is negative 9 and 6. So I have a horizontal translation six, what? Left or right? Left, because I have an x and I'm subtracting 6 off of it. So I'm going to eventually be moving myself to the left. And I have a vertical translation. One, up or down. I have a y, I add 1 to it. I'm going up. Okay, example 7. Describe how the graph of the second function compares to the graph of the first function. Okay? This is key. These are all different weird functions. Last year you did transformations on a quadratic and on nothing else, right? Think about it. With a quadratic, there was brackets and a squared, right? If it was in the brackets with the squared, it was with the x. We agree? If there's a radical function, you just treat the radical symbol like it's the bracket formation. If it has absolute values, which are the lines, that's your bracket portion. That's with your x, okay? So if it's with your x under the radical, if it's with your x in the absolute value, or if it's with the x in the exponent when we get to exponential, or if it's with the x beside the log when we get to logarithms, okay? Then it affects the x. So don't freak out when you see a different function. It's not super complicated, okay? First thing to do is not freak out. Second thing is, describe how the graph of the second function compares to the graph of the first function, keeping in mind that the first function may already have transformations. All right? So let's look at this first function. This is the original. Is it transformed at all? No, it's a polynomial function. We're going to be dealing with these next unit. So we're doing transformations on polynomials. Could I ask you transformations on polynomials now? Absolutely. Can't ask you to solve them or anything, but the transformations don't change no matter what function I give you. All right? What's the only thing that changed here? I have a plus 3. Is it with my x? No. Remember when you had x squared plus 7? Was it with your x in quadratics last year? No. Teacher probably said, hey, just put a bracket around that, right? Because the squared is to this x. But this is really just bracketed. But do we put a bracket on a basic x? What's x times x? X squared, right? That's why there's no bracket there. What's x times x times x times x? X to the 4. That's why there's no bracket there. But technically the bracket is right here, is it not? So is that 3 with the x? No. So what is it? It's the vertical translation. I'm being lazy. I am putting VT on the written response on a unit test or on the diploma. If you put VT, are they going to be like, oh, that means vertical translation in shorthand? No, there's nowhere a dictionary in the math languages that says VT represents vertical translation. And if there is no dictionary that they can look at that can look up your shorthand and say that that means vertical translation, they will not give you marks. Okay? Do I care if in class you put VT? No. Do I care if in your homework you put VT? No. I don't care if you know that that is vertical translation and you can spell it and write it. Okay? If you can spell it and write it, you can do that. But on a written response on your unit test, if you write VT, I'm not giving you any marks. Keep that in mind. Why am I being that mean? Because will they give you marks for it? No. So I'm going to mark you the same way. So I'm putting VT. Would that be a good thing to put on my unit test? No. Vertical translation 3 what? Up. Okay. Let's look at B. What does B have in my original equation? Y equals 6x minus 3. We agree? And this is a linear function. Line. Looked at those in grade 9. Now, the 6 was here. The 6 is still here. Is there anything happening? No. Minus 3 was here, so I was down 3 to begin with. That's what that means. And I'm still down 3. If this was minus 6, I would have moved how many? 3 down, not 6 down, because I was already down 3, and now I'm down 6. So what did I actually move? 3 down. Okay? It's not. It's the same. It's nice. The only thing that's changed is this. So what's the only thing that's happened here? Horizontal translation. Can I put h of t because I'm just not writing on a unit test right now? Yes. Can I do that on a unit test? No. You're going to be like, we get it, Lepp. And then you're going to put h of t on the unit test. And I'm going to like little tears, or big tears. And I'm dehydrated, and it's going to be on you. Okay? When I'm dehydrated, I have to go to the doctor. It's on you because you put h of t and didn't listen to me. Okay? I actually rhymed right there. H of t didn't listen to me. All right, h of t, 1. Right. Right is right today for that particular question. All right. This one has a really funky absolute value sign. I should freak out. I just, the song came in my head. Freak out. No? Okay, good. All right, I have 2 smiles. I'm winning. That was more than the 0 smiles I had before when I was super funny. Kind of got a little bit of smile from you. Okay, so we're winning. Absolute value signs. We don't freak out. Those are just fancy looking brackets. They're not really, but we're going to pretend they are because that's all we need to worry about. Fancy looking brackets. We agree? Okay, so this is with the x. So I have a horizontal translation, 6. I'm willing you to tell me what it is. 6 to the right. Does it change anything different because I have absolute value sign? No, it's still the opposite. Vertical translation 2 up. Now I'm going to remind you where those absolute value signs are just so that if you want to be able to look at it, you can. Does this have a little F in it? Is there an F in there? That means we can't type it into our calculator? No, so what can we do? We could type it in, right? If there's an F, we can't type it into our calculator. If there isn't an F, we can. So let's go to our graphing calculators. And I don't remember what it was. Math. And then you go over to number, 1 over, and there's apps. Now mine are going to actually make it look like absolute value functions. Yours might say abs bracket if you have the TI-83s. Is that absolutely fine? Absolutely fine? Abs. Okay. Yes, it is. Thank you. Just close the bracket and it makes you have, it's an absolute value looking graph if you have the TI-83s. Don't freak out. Here's the song back again. It just did it. Okay, enter. Well, now I have it on my main screen. Is that where I wanted it to be because I want to look at the graph? No. I want to go to my y equals. Clear out that quadratic. And I'm going to go math over to number, abs. There she be. What was the second function again? X, something, something, something. x minus x. And then if this was the TID3, you'd close the bracket, right? Boom, absolute value done. And then minus what? Plus 2. Now this is the thing. People will get different questions, different answers, let's say. You have to put into your calculator the way you speak. So, and hopefully you don't speak wrong, because that would not work for what I'm telling you right now. But absolute value, x, do we say minus 6 or do we say x negative 6? X minus 6. If we say x negative 6, how does that change the question? You're multiplying. X negative 6, you don't have a sign in there. If you don't have a sign in there, or a symbol, or operation, there we go. X negative 6, our operation is multiplication, right? But if we want a minus, we have to go x minus 6. We agree? They're totally different functions. You have to say it the way that you put it in the way you say it. So if x minus 6, go x minus 6, not x negative 6, right? That's multiplication. All right. A bunch of people look for me over and they're like, it does not look the same. And then I'm like, you use the negative. And they're like, oh my goodness. And then they just, yeah. Okay. Remember, absolute values for the most part look like those wonderful little V's. We did absolute values on quadratics last year too. They did the two arms and the bubble in the middle. Remember that? Yeah. Or they did the bubble just in the middle. No arms, because the arms were negative. Okay. I don't know where I am. Here. Okay, and then this one, does it matter the radicals on the bottom? Should that throw us off? I've never seen this before, therefore I can never do the question. No. No, Sean, we can do the... No matter how I blink it, that's still a phone. It's really weird. Like, I was just... but I'm still talking. You might be wrong. Chem 35 for the second time. What are you going to do in Chem 35? Oh my gosh. Oh my gosh. I don't even know. Or the best options. I say best. I still think foods would have been a better option, but that's just me. Oh, I'm horizontal stretching before we're stretching, guys. That was my erasing. Horizontal transfer to the people who re-listen to this. Horizontal translation, because I have such a following that I don't want to lose them. Horizontal translation, 1 left. I don't think I have a following at all. I don't even think you guys are watching. And then a vertical translation, 3 up. Okay, we're going to write an equation for the image of. So this one says y equals x squared after we do a horizontal translation 3 units to the right. So what are we going to get? Y equals x. I'm willing to use the right answer. X minus, because when we put it back in, it's the opposite. 3 bracket squared. B, y equals 10 to the power of x. It's an exponential function, which we will be doing this year. After a vertical translation, 2 units up. If it was right or left, it would join here. So we'd have y equals 10. Say if it was 3 to the left, we'd go x plus 3. Okay, it would join our x. But it's not that. So where's it going to go? Y equals 10 to the x plus 2. The same height as that 10, right? If it's with the exponent, it's with the x, and we don't want it with the x because it's not vertical. C. Y equals square root x after horizontal translation 4 to the left, vertical translation 3 down. So y equals square root x what? Plus 4 under the square root, because that's just like our little brackety thing. It's with the x. It's under the square root. It's with the x. We need to be with the x because it affects the x. And a vertical translation 3 down. Here, the function represented by the thick line is a transformation of the function represented by the thin line. Which one is the transformed function, the thick or the thin? The function represented by the thick line is a transformation of the function represented by the thin line. So then the thick one is the what? Transformed. I know, so sometimes you have to read it like 14 times because it's like slightly confusing. That's transformation. Okay, so this is the one that's moved. These are really easy when there's only horizontal and vertical translations. It gets substantially more complicated when we add stretches. Okay, so here we're going to go 1, 2, 3, 4. What? Down, and then 1, 2, right. So we have 4 down, 2 right. So we have to write our equation. Our equation is y equals f of x, because look it tells us that. We need to move 4 down, 2 right. So we're going to go y equals f x what? Minus 2, and then minus 4. Make sense? B and C are redundant, so we're not going to do those. Flip over. And honestly, this is not the issue. Moving graphs when it's horizontal and vertical translation. It's when I put all of them on and you're like, oh. But you'll be fine, because I have a method, and it works every time. Okay, example 10 is our last one, and then there's some homework. Okay. Y equals square root x is a radical function, so that's our original. Okay? Every function that I give you, you could come up with a coordinate off of it, couldn't you? Remember grade 10, 9, we had to come up with tables of values off of an equation. So they'd give you like y equals 3x, and they'd want a table of values. So you'd go x, and you'd go y, and you'd pick x's, random ones. Usually it was like -3, -2, -1, 0, 1, 2, 3. And then you'd solve for the y's using that function. Then you plot the points, and boom. Grade 10 was so nice, wasn't it? Boom, boom. People thought it was hard. But reality, once you get grade 12, you're like, oh, I'd love to go back to that. That was fantastic. It's how it is all the time. You go to university, and you'd be like, I'd love to go back to grade 12. It was fantastic. Yeah? Okay. When you get to proofs, a whole bunch of like one of my, it was Math 2000. It was a long time ago. And there was very little numbers in it. It was like, if birds can fly, then they have wings. And you have to do the contrapause. If birds cannot fly, then they cannot have wings. And then you'd have to state if it's true or false and why. And I was like, there's no numbers. Why is this math? So, yeah. Or the one time it was like, oh, I'm still talking, but whatever, I don't care. So then there was proofs for infinitely many prime numbers. And they're like, if, and then they'd start with an upside down A for all elements, an E with an R. So it was like, if for all elements of the real numbers such that ST, da 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 da. And then he'd be like, board, writing, all that. And then move to the next board, writing, all that. Then he moved to the next board, writing, all that. And he's still proving this proof that there are infinitely many prime numbers. And I'm like, sweetie, he at the end of the board, he's going to have to at least erase. Nope, there's slidey boards. He's just like, pushes the board. It goes sliding across. He's got another board underneath, starts writing on it. I'm like, sweet, he's done that one. I have time to breathe. Nope. There's another slidey board under the slidey board. There was 5 boards. I was just like, oh my gosh, why? And then in the end, it was like, ... Therefore, there are infinitely many prime numbers. And I'm like, sweating. And I'm like, I have no idea what just happened. There was a lot of upside down letters, backwards E's, some R's with double slashes. There is a lot of things going on, sentences, so many sentences. And then therefore there are infinitely many prime numbers. And I'm like, sweet, you proved it. This is good. I trust you. Can we just move on with this? And he's like, you must know all your proofs for the test. And I was like, I don't even know what had just happened. I think I just died and came back another person. I think it was just so bad. So yeah, this is great. Grade 12 math's great. You have no idea. It's fantastic. Yeah, it's true. But what I realized and remember now for most of my math is there are infinitely many prime numbers. You remember that, okay? It's true. It's real. There's a proof. It's like a 5-board proof. Lots of writing, but it's real. All right. And proofs, you can't unprove because you only use variables and statements throughout the whole thing. So you prove that it works for every example. So it's no longer a theory, it's a proof. So it's real. Hashtag truth. Hashtag holy crap. Oh, I just said that on there. Holy moly. Can't undo that. Can we like retract things? No? I want like a redo. No? But you can delete podcasts. This is true. Okay, and then it never happened. Okay, so I don't know how I tangented again, but we're back. What vertical translation will be applied to y equals square root x so that the translated image passes through this? So we wanted vertical translation. That means there was no what as well. We're vertically translating it, but what did not get affected? The x didn't get affected. So the x on the original is the same as the x on the new. We agree? And they're saying what vertical translation would be applied to y equals square root x so that you get this point. So is this point new or old? Original or new? New. So we have to find the original, but we can find the original. We were taught like by 18,000 examples in grade 9 and 10 how to get t-table, right? X, y. So we know our x did not change. So can we find our original y? Yeah. Plug that in for x. Okay, so we're going to go y equals square root 16. So we have a little t-table. We know our x is 16. We are finding our y. See, it's just grade 10. All back again. And so we have y equals what? 4. So our original point was 16 and 4. It's now 16 and 7. What happened? Vertical translation, 3. Where'd we go? We were at 4. We are now at 7. Where are we moving? Up. Would I accept VT on a test? No, I would not. Remember dehydration and tears. Don't be that person. Okay? This one, they just give you a horizontal translation, so your y doesn't change. So you plug in for your y, solve for x. So we get 8 equals square root x. How do we get rid of a square root? Square both sides. So x would equal 64. So my coordinate was 64 and 8, original. It's now 17 and 8. Where did I move? Left how many? Yeah,